Okay, so we're gonna try to power this off of a Apple phone charger, 2.4 amps, 5.2 volts, and I have it connected up. Now, it doesn't actually work. If I turn it on, you'll see it does this. It moves very slightly and it stops, so I'm thinking it's power cycling because we're trying to draw too many amps. So what I've done here is I've measured this length of wire from 0 because I can't even measure it with this. The leads itself has around 0.01 ohms of resistance, so this is roughly 0.02 or 0.03, so the results in around 3. Okay, so after Thanksgiving break, finally I got to test it, so it works on the nano board thing. So we have the head turn. Did I twist it?
Kind of laggy.
No, never mind. I was twisting it the wrong way. Still somewhat laggy, but it's not my problem. we're gonna replace this anyways because this is horrible. Though with the nanos, we could program like a sequence into it. So, I mean, we could do that with it, but we're definitely replacing it with the NRF when we get that working. Nick, wait, does the mouth work? Yes, still with a lot of lag and sometimes not working. Yay. But yeah, we're gonna replace it with NRF. This is trash. So we're gonna try making another muscle using the fishing line we had the first time, and 34 gauge nichrome 80, which I calculated using 2 feet, 12 volts. We're gonna get 32 ohms and a current of 366 milliamps, and the calculator works. I got like pretty much exactly 32.7 ohms when I measured the 2 feet of nichrome, but I include some excess, so close enough. We don't have the Dremel, so I'm just gonna apply pressure on here with my hand, and Luke, you can hold that down with your foot. Your foot, like, it's like step on the motor. It doesn't really matter. Don't click the switch though, because okay, good. So well, because I'm out of hands, I'm not gonna record this until it gets interesting.
Wait. I can press the switch. Wait, this?
Yeah.
Okay.
Just like press it and then stop when I tell you to. So this will take a while. So this time the nichrome I loosely wrapped around the ends of the fishing line, so that way it can relieve tension. And you can see now it's starting to coil the nichrome into it, and I can feel some force on this side. So instead of pulling on it, I'm just gonna press down on it because the carpet applies friction. And with luck, some tension, not quite enough. No, it's gonna take a. You'll know when to stop it when you see. Okay, starting to pull inwards. I'm gonna release some of the tension, and we'll see. It's inching forwards. That's good. Starting to do the thing.
No, over there.
Oh,
Yeah.
That way. It's doing the thing.
Bit dark to get good quality, but it's doing the thing. Though the nichrome seems to have gotten tangled up in the fishing line, so we're gonna have to test that a bit differently. But I'm gonna try keeping a bit more tension on this thing. The thing with nichrome is that you don't want as much tension as with the plastic because the nichrome's not flexible and it'll snap.
Oh!
Right when I said it snaps, it snaps. I jinxed it. Let's go. Oh, never mind. Oh.
Poink! okay.
No, we can make it work. It's salvageable. Okay, second try works. I'm doing yoga while managing this.
Hold on.
Nope. I'm doing it already. You're gonna mess it up. So now we're trying to heat it up. Well, I'm trying to heat it up. So I got it connected to power supply, and I'm literally putting my finger on this and power cycling it on here. So let's see. It's getting warm.
How good is this? I'm gonna test it out.
We might need a few more amps. No, I can feel it. So just let it do that for a little bit, while making sure the temperature doesn't get too hot. Around 50-60 degrees. So this will take a while. Let's try powering it. So I'm gonna set this here so it does not move. And I know it's hard to see, but I'm not gonna move the phone. I'll connect power.
Better than these. So it'd be like, so if you put it in here, it would be like out.
And
out
it lifts. Disconnect. Is it getting hot?
No,
It is, okay.
Let's add a water bottle.
We have this cursed thing. It's very heavy. So this is only a small section. If we zoom in a lot, and we apply, and we apply power, and it's not making. And it's not making connection again. Just that. Still nothing.
Autistic.
Now you will see.
No, we have to match.
Shrink. And it got too hot.
No, hold on. Wait, if we put this
Ah.
on.
Shit.
That's why we need temperature control. So we pretty much got the head, at least the actual mechanical parts of it working, and we can hook it up to a remote. So that's a good thing. Now we just have to build a better remote because the current one, which is bodged from a car RC remote, is not the best. So yeah, we're gonna use the NRF controller for that. And ideally we'd be able to send sound over radio as well, because we don't want a computer hooked up to the actual thing in the end. That would be ideal if it's a separate thing, because then, well, you know, the robot has to be mobile, so we don't really want like a computer or a laptop on it and running a power cord off to an outlet. So the computer should be doing, the computing should be done on a separate thing and just transmit it over. Now, the good thing about NRF transceivers is they're transceivers. They can transmit and receive on the same module. So using this, we'd be able to send instructions to the eMove, and the eMove can send back a code saying whether it worked or there's a failure here or there. That's going to be useful for the muscles. Speaking of muscles, because we're going to need temperature control, ideally we'd use some sort of heat temperature sensor. Most likely a thermistor, as they're easy to read. It's a resistor that changes resistance with temperature. So that's pretty much just a voltage divider in the end that we have to read off of, and they can have a common ground. So we need that for each section of muscle, I guess, like ligaments. Let's call them, I'm going to call a group of muscles a ligament because that's easier to say. So that's how we're going to do that. We're going to use thermistors on ligaments, and ligaments are going to be made up of multiple identical muscles. So for now, for testing purposes, I'll rig up my PID controller to have temperature cycling so it works better, but in the final product we don't want that thing in there. We want a actual, like, built into the Arduino. So the transmitter side is probably going to be a Nano. Receiver side is probably going to be a Uno or a Mega maybe, because we want to be able to have a lot of connections to that thing. Now, we could also still use the Nano board I built, because the nanos are not really hardwired in. We can jump off separate traces and all that kind of stuff. And that's pretty much all we have. Oh, the eye mechanism. We're going to run 6 servos on a servo driver board, so that thing pretty much just takes 4 pins, four pins, and it changes that out into multiple servo controllers. So we're going to do that. That way we can drive the eyes using a single, we don't need more than a few pins on a Nano for that. For the remote, we're going to probably have 2 joysticks, because using potentiometers is a bit weird. So 1 joystick for the head movements, neck and head turn, and 1 for the actual eyes, and a button to open and close the eyelids, or probably have that on some sort of a cycle so it does that automatically. And because we're going to use a Arduino for the actual eye transmit, or we can have it generate random numbers, so we can actually have the eyes move on their own, which is going to be a little creepy, but yeah, so that's pretty much all I got to add to the addendum.